Here's Precal 9.2.3 lecture. We already did 9-123. We're going to do 9-124 and 9-125. So 9-124, it says let P equal -2, 4 and Q is 6, -2. Locate R, the midpoint of this segment joining P and Q. So I actually drew P and Q. There's P and Q. And I found the midpoint by just looking at, I just drew a triangle right here, and I found the midpoint. I saw that from the top to the bottom here, that's 6, and across was 8. So if I knew if I went down by 3, and across by, from here to here, if I went over 4, that gives me this point right here, which is 2, 1. So graphically, I know that that's the answer. That's the midpoint of this line segment, but I want to remind you that there's a formula for that, the midpoint formula. So you might remember that if you took Algebra 2 or something. You just add the x's and divide by 2. It's like the average or the mean of the x's, and then you add the y's and divide by 2. And so I just worked it all out just so you can see how to do the math. So this is one that those of you who love to have a formula sheet with some formulas, you want to add that to your formula sheet. Or if you're one who just likes to just draw the picture and figure it out using logic, then I've shown you how you can just kind of draw it and find the midpoint graphically. So anyway, it said that was letter A. It said locate R, which is the midpoint. Now, for the matrix T, this transformation matrix, what are the coordinates of the image of if I transform P and transform Q and transform R? So T times P, T times Q, and T times R. So I'm going to grab P, Q, and remember R was the midpoint. They all have ordered pairs, so I'm going to do, don't be surprised, but I'm going to do the same thing I did in the last problem. This right here is my transformation matrix, and these are the 3 ordered pairs, the endpoints, and that was the midpoint. And I multiplied, and we remember how to multiply. -2 times 1 is -2, plus 2 times 4 is 8, and then when you add those, 8 plus -2, that makes my 6 right there. So I multiply them, and I get some new vectors, or you can say they're ordered pairs. Okay, so what was I trying to do here? Oh, what are the coordinates? So here's all the coordinates. What can you conclude about the relationship among TP, TQ, and TR? Do you believe the same relationship holds for any matrix and any 2 points and their midpoint? Explain. So, C on the back. Where is C? What we're supposed to say is that these things are, they're collinear. And so let me get my, oh, there it is. Hold on. Yeah, we're supposed to say, so here's the answers that I just showed you right here. So they just wrote them as ordered pairs. And then it says, what can I conclude about the relationship? TR is going to be the midpoint of TP and TQ. This relationship always holds true because the matrix multiplication is a linear transformation. So I thought I had graphed those somewhere, and I probably did, and I probably just did some math on the back of it and maybe threw it away, I'm not sure. But if you want to, what you can do is graph these three on a graph, just like I did here, and you can prove to yourself that these are collinear. Actually, I think that's what I was doing right here, is I went ahead and I used my midpoint formula on them, just to make sure, because I got this as, this should be the midpoint. This should end up being the midpoint between these two. And so what I did is I added the x's together, x1 plus x2, that made 8 over 2. And then I added the y's together, 22 and negative 14, I think that also makes 8. And divide by 2. And so that kind of proved it, so I didn't really have to graph it. So maybe that's why, maybe I didn't graph it, I just proved it. But just know that linear transformations, I don't know, preserve the linearity of it. So matrix multiplication is a linear transformation, is the proper way to say that. So that was, I guess, letter C. And then now we're on 9125, and that's on the back. So 91 on the back of this page that I drew here. So 9125 says, let T equal this transformation matrix that we have here. I'm going to push autofocus. I think that helped. It wants me to graph these points and describe them. So I think I did. I graphed, there's the 3 points that they gave me. 0, 4, 5, 4, negative 4, 4. And the description that they wanted me to give was that they are collinear. They're collinear, they're in the same line. They line up. And then now I take my transformation matrix, it's the same one all the way down, and I'm going to multiply each of these 3 points by that transformation matrix, and then I'm going to get new points. And these new points, this is going to show that they're collinear. The new points will also be collinear. So I actually did graph these, even though it was kind of a pain. I made little tiny marks and I graphed them, and they did line up. So they are collinear. You can check it. And then so letter B, yeah, says graph it, describe the points. We're supposed to say that they are collinear. So now, then letter C, it says graph some more points. I'm going to leave that to you guys. Graph these 3 points. Create your own transformation matrix and use it to graph the image points. And then what do you notice? Well, you get to make up your own transformation matrix, and then you get to notice what happens to these 3 points. You're going to multiply your transformation matrix by these 3 points and compare your results with your teammates' results. And then what conclusions can you make? Well, what's supposed to happen is you guys are supposed to all make up your own matrices and then be very amazed that your points will still line up after you've used the transformation matrix on them, even though you have everybody has different matrices that they made up. So I think it's worth it if you have time to go ahead and, try doing this for yourself and see if you can just make up your own little matrix and multiply the points and then graph them on a graph. Just like, well, it's kind of ugly, but do what you got to do. And that's it.